Hello everybody, this is the second in a series of videos on reasoning and proofs. In this video we're going to talk about propositional logic, including statements, compound statements and truth tables. Actually in the next video we'll do these next three. Okay, so what's a statement? Actually a lot of people call these propositions. I prefer that terminology, but we'll stick with statements. So the blue things on the left here are statements. The purple ones on the right are not statements. What's the difference? Correct. These are just sentences that can be true or false. These are either questions or imperatives that are requiring a response that is not true or false. Okay, let's have a look at these statements. So Paris is the capital of Germany is a statement. Of course it is false. Hats are cool is a statement. Maybe it's an opinion, but it's a statement, and I'm going to declare in this case it is true. Pens are this pen is black is a correct statement. The pen that you can't see me holding right now is actually black. Here I'm trying to be a bit topical, you know, Billie Eilish, whatever. I'm probably 3 years too late. I am a bad guy is a false statement. Black Lives Matter, I'm going to choose to say that's a true statement, even though I don't agree with all of the BLM organization. I think it's hard to argue that black lives do not matter. Of course they do. And I am a believer that God is love is a true statement. The negation of a statement changes it from true to false, or from false to true. So I'm a bad guy. The negation is I am not a bad guy. Now, here's where this nuance is important. It is not I'm not a guy. It's not I'm not bad. It's not I'm a good guy. It's just that I'm not a bad guy. Doesn't mean you're a good guy, just means you're not a bad guy. Doesn't mean you're not a guy, just means you're not a bad guy. Right? It's important to get the nuances clear. God is love. The negation is God is not love. It's not God is hate, or God does not exist, or love is a social construct. No, it's just adding in that one word, not. All polygons have four sides. Of course, is a false statement. All polygons do not have four sides is a true statement. It's a negation. It's saying not, but it is true. Okay. Normally we use letters P and Q when we talk about statements. P because it's a proposition, really. So here's a P stands for the Cowboys are the best rugby league team in Australia. So you would have a P because it saves you a lot of words. So this symbol means not P, means you can read that there. Or the triangle ABC is isosceles is Q, proposition Q, statement Q. So not Q just means triangle ABC is not isosceles. We make compound statements by joining two statements together with an and or an or. P, Billy has green hair. Q, Billy is a good singer. So P and Q, and we use this symbol, means Billy has green hair and she's a good singer. This symbol, easy to remember, it kind of looks like an N. So you'll remember it looks like the N here, so that's how you know it's an and. It's also called a conjunction, just like in English grammar you call it and a conjunction, but this is particularly in maths, it's just the and that's the conjunction. And it is true if both statements are true. And I'm going to talk more about this in a few seconds. The other compound statement is or. So if you see this, it looks like a V. It's not really a V, it's an upside down and. So P or Q means Billy has green hair or she is a good singer. This is called a disjunction, and it's true if either one of them is true. Okay, I'm going to show you more about these things I've said here with a few examples in a second. So again, this quadrilateral here is a rectangle, is P. Q says this quadrilateral is a square. I'm not sure which one is true, but with these statements, P and Q means the quadrilateral is a rectangle and a square. P or Q means the quadrilateral is a rectangle or a square. Now, this first one, P and Q, is true if, only if, both of these statements are true. P or Q is true if one of these statements is true. So if it's a square, then both of these are correct. If it's not a square, if it's just a rectangle, then only this one's correct. This one would be, sorry, not correct, but true. This one is true, this one would be false. Okay, you can maybe visualize this better if we use a Venn diagram. Venn diagrams are really cool and really useful for a lot of things, but without going too deeply into it, let's say that every person in the world with green hair is in this blue circle here. Okay, Billy has green hair, so Billy's somewhere in this circle. And all the people in the world who are good singers are in the purple circle. Okay? So, if Billy is both a good singer and has green hair, she will be somewhere in the conjunction, in the intersection here. P and Q. If she is just one of them, she is a good singer or she has green hair, she will be somewhere in either of these circles. Yeah? But if she's anywhere in these circles, this statement will be true. Okay, here's another example, but this is a different type of set. Okay, so here we've got P is inside Q. All right, because Sydney is a place in Australia. So if you're born in Sydney, you are born in Australia. So if we say John was, I was born in Australia, in Sydney, and I was born in Australia, you have to be inside that circle. I'm not. I'm somewhere here. So I was born in Sydney or I was born in Australia. That is true of me, even though I wasn't born in Sydney. This is false of me. This is true. But this, with the or, is also true. Okay, so you can see there's a few complications here with the working out what's true and what's not true. So one tool they use is truth tables. Okay, so here's an example of some truth tables. You have statement P. It can be true or false. And statement not P will be false or true. Yeah? That's the negation. Just changes true to false and false to true. If you have two statements, and this is where the truth tables are useful, when you have two or more statements, so P could be true or false. Q could be true or false. So the combinations you could have are true and true, true and false, false and true, or false and false. So these tables make things a little easier to see. So let's see some examples of these compound statements. So if you have P is true and Q is true, what is P and Q? Is it true or false? Well, let's use the example to help us make sense of this a bit more. Okay, so if it's true that I live in Australia, I was born in Sydney, sorry. And if it's true that I live in Australia, then I was born in Sydney and I live in Australia will be true. If it's true that I was born in Sydney but I do not live in Australia, then this statement will be false, because only part of it is true. Okay, if I was not born in Sydney but I do live in Australia, okay, only part of the statement is true, so it can't all be true. If I was not born in Sydney and I do not live in Australia, then this statement cannot be true. But what about with or? Well, if I was born in Sydney or I was born in Australia, if both of these are true, then this statement is definitely true. If I was born in Sydney but I don't live in Australia, this statement will still be true, because or just means one of the parts of it has to be true. So obviously this one will also be true. But if both of them are false, then the whole thing will be false. The compound statement will be false. Okay. So this kind of analysis really makes you think, and it's something that really only comes with a lot of practice. So I suggest now you go practice. All right, ask your teacher for some questions and get into it.